time.
Hi everyone, Kerry here. We're at day 2 of BB8 Builder Arizona BBA-Z 2018, and the last subject that I'm going to be doing for this group is drivetrain basics. Not looking to get into a lot of in-depth stuff, but just to give the basic idea of how these things work, the differences and what some of the differences aren't at the same time. And then the only thing I don't have here is a hamster drive, so I'll just discuss that. Let's go through basic. There's 2 different main types of drives. There's what they call an axial or a pendulum drive, which is this style, and then a hamster drive. We don't have any hamster drives here, but the best way to describe it is a fancy remote control car and a ball. And I'm not trying to be crude or disparage anybody, because I've seen some of those drives that actually work extremely well. But if you picture a remote control car in the ball, as it drives up the side of the ball, the gravity will keep it rolling. And then from the remote control car, like I said, I'm not trying to be mean, but it's the best way to describe it. There's a shaft which comes up, which has magnets on it, which is exactly what we have here. And this is how the head is actually held on. There's magnets inside of the body and magnets inside of the head, and they attract to each other. And then the head has a couple different types of things to hold it on or have it roll. Most of the time it's casters. So it's essentially just a head rolling on casters. The magnet keeps it together, and that's how the head moves. And that is common to both the hamster and the axle drive systems. Going to go through axle drives. That's kind of the basics on the hamster. As far as an axle drive system, we have 3 different systems here. There's Joe's drive. This is my V1 drive, and then we have Dave's drive. And the commonalities that you'll see between them is they all have an axle. And what the axle does is essentially mounts to either side of the body. You'll see on this one I've got marking here. Generally mounts to this point on the body, and then it'll mount on the opposite side, just like this. So the entire drivetrain is actually hanging inside the body. So it's free floating. And what happens is we've got a motor in there. My motor is actually mounted, I don't know if you get a shot. My motor is actually mounted up inside the center box. And what happens is as the motor turns this belt, it spins the axle. So as the axle turns, the weight which is down here on the bottom, which we'll talk about in a second, the weight goes up the side of the ball. Well, it wants to go back down to gravity, so what happens, the ball rolls to try to put the weight back down to the ground. So the only way he's moving backwards and forwards is simply by shifting this weight backwards and forwards. At the same time, BB8 has the ability to ride like a bicycle, for lack of a better word. So what will happen is as he's driving, you'll see he kind of rolls, and that's how he turns while he's driving. Well, how that works is the whole drivetrain can actually, this is straight up and down. This weight, this weight will go up, and then it'll want to drop to gravity. So what that does is that actually takes the entire ball, shifts the ball to the side. So once again, it wants to chase gravity, and it'll roll like this. The other thing that you'll find common to all of them, and we've actually taken it off of this one for show and tell, is they usually have some sort of a weight at the bottom. This one is actually just printed out of PLA. We did this just for show and tell right now. And then usually it's filled with something. I think the common thing here is lead shot. Could you grab me? I've got, oh, here it is, sorry. It's in the tail. So most of the time what we do, this is an old heavy one, we'll go ahead and fill it with lead shot and then use some sort of epoxy to cover it. And some people have made printed covers that go over to kind of hold it in place, but this is more or less the final result. So that's the weight that's chasing gravity. And then what we have on top of that, I'm going to show you on mine simply because I'm not sure where it is on some of the other drives.
Are you like a flywheel spin?
Yeah, like my flywheel spin is here.
Should be in the other A-frame on Joe's too.
Okay, I'll take a look at that one in a second. Oh, I can see it in there. So the other thing is this piece here, thank you, sir. This gear motor here connects to a gear, which is essentially on top of here. What happens is when you fire this motor up, it spins the weight really quick. When you spin that weight in one direction, what centrifugal force makes the droid want to do the opposite, essentially. So that's what allows him to spin on the spot. From there, as far as the head control, or as far as the rest of the body, everything just kind of hangs off of this axle in the center box. From there, as far as how the head actually moves around, these three, or at least these two, are extremely similar, and what they have is they have two different boxes. And the boxes actually move, you can see here, forward, back, side to side. And same thing with this drive. And that's what allows the head to move around in this type of orientation, no matter where you want it, front, rear, side to side. And that's what gives them his character. And then when we rotate the magnets on top, I think we're all three, these two have servos that rotate this via gears, and Joe's using a motor down here, but it's all the exact same concept. We're rotating the magnets, which are attached to the head, which in turn rotates the head at the same time. The main difference between the drives, more than anything, if you start looking at them, there's some that have more metal, some that have less metal. When it comes down to, which drive do I pick? In reality, spend your time, if they're available at that time, spend your time, look at the different drives, research it. You may find out you're better off building a drive that your buddy's already built that's 2 doors down, because now you have somebody to lean on during the build process. You may find that you want to build this drive because you think worm gears are cool. You may find you want to build Joe's because you think that 3D printing and doing all this stuff is really cool. So there is no way for me to stand up here and go, better, better, better. It doesn't exist. A lot of it's preference. Just like BB-8. Some people want to do orange. Some people want to do gold and black. Some people want to do, we've got a green and white one over here. But that's the basic on how they work in general. And I can't think of anything else. Oh, I'll do a couple of little things here. Because people may not know. This is called a slip ring. And you'll see that a couple of the drives have it. This one's off right now. What the slip ring does is this allows us to take power and commands from this portion of the body, and as the axle moves, allow it to go with the droid. So for instance, on this one, we've got a speaker because we use a transducer on the body, and another one for NeoPixel lights. That way when we turn on the drivetrain, the ball lights up as well. We don't have to have a separate battery. So when the axle turns, what you'll notice is the wires on this side stay still, but the wires on this side move with the ball. I'm trying to think of anything else as far as the basics of how it works. There's different type of control systems. I think all three of these use a custom remote that's been built. I believe these two are working on Arduino. And what does Dave's run on? Matt, do you know?
Vex Robotics.
Vex Robotics.
Part of it, and there's another company called CTR. Cross the Road.
Okay.
Electronics.
The only thing I would bring up too is see where you live about sourcing materials.
Yeah.
Like, there's sometimes you can't get magnets overseas that we use or whatever here and
Yep.
back and forth too.
Yeah, it's very true. What you'll find is a lot of the drives that we're designing right now for the club, and at some point I think all three of these are going to be available to the club, we try to use off-the-shelf stuff. A lot of mine has Servo City gears, little clamps, things like that. A lot of it's been 3D printed. The magnets are sourced here, but they're my current BMM DMM, which is 1/2 inch by 1 inch, which overseas it's going to be a 20 millimeter by 12 would be kind of the closest, or 25 millimeter by 12 would be kind of the closest thing out there. So we've got Servo City parts, gearboxes from Servo City, gear motors from Servo City. There's Amazon parts on here. There's Hobby King parts on here. So it is going to be a mixture of different things, but that's a very good point. When you're researching the 3 different drivetrains and we give out the BOM, which is the bill of materials, what puts it together, you may want to do some research and go, you know what, I can't get, no matter what I do, I can't get this motor in Sweden, or wherever you happen to live. So that's a very good point. I'm trying to think about anything else that could be covered. Does anybody have any questions? Because they may spur something in me that I forgot. Nada? Basics are covered?
Yeah, I would think so. I mean,
Awesome.
engineering, or not engineering, but design-wise, we're kind of all those three drives are kind of the same thing, no matter what, but just a different approach for each one.
Yeah, that's exactly it. All three of them have the ability to tilt, but this one's using a servo with a line gear to tilt. Mine uses a servo with an arm to tilt. This one uses a motor with a potentiometer to tell where it's tilting. So the end result is all the same. The controllability of every single one of these is extremely similar. I think the only real difference I could say is this head only goes forward and back, but he's working on a revision to make it go side to side. So I'd say within a month, if you were to close all three of these up in a ball, say the programming is all the same, if you were to close all three of these up in a ball, you'd probably never be able to tell the difference. Mm-hmm. Or it'd be so minimal that 99.99999% of the people could never tell the difference. So don't do a drive because it's Joe's drive or my drive or Dave's drive. Do the drive because it's something you can afford to build and you can get the parts in your area. And like I said, I personally think that having somebody you can lean on is huge.
Pick your skill level.
Pick your skill level, exactly. As you look at the builds, and because they're going to be available for people to see, as you look at the builds, start looking at the complexity of it. And that's a huge point, Matt, because some of these, even though they look similar, putting it together is much more complex. Any other questions?
Somebody's asking for motor, stepper or not.
None of them are stepper motors. They're all using planetary HD motors, I believe. What does Dave use?
It's planetary.
Planetary as well. So yeah, they're all planetary stepper motors.
Planetary gear motor?
Gear motors, sorry. Gear motors, not
There's no
steppers.
point of using stepper motor.
Yeah, this is what happens when you're up for days at a time. Some of them, like Joe, is using, I don't know if he has any servos, it's all gear motors, right?
Yeah, no servo.
It's all 100% gear motors with potentiometers. And the potentiometers tell the drive where the gear motor is, which allows it to give feedback to the drive system so then you can control it. Mine's a combination of, so I've got gear motor for the flywheel, gear motor for the main drive, everything else is servos. What do we have in Dave's? We have a gear motor for the spinner, and yeah, servo here, gear motor for the drive, servo for tilt, servo. So from a conceptual standpoint of how it's done, these two use the same thing. Spinner motor and drive motors, and everything else is servos.
Talk about choice of servos.
Oh yeah, that's huge. Good point as well.
Don't go cheap.
It's been a big learning curve as we've been designing these drivetrains. This drivetrain, which is the V1, I actually had in my robot I got in there a week before Rogue One. And that was after like a month of straight work to get it done before Rogue One. And I got it ready before Rogue One, and it was awesome, and it was on the bench, and it moved, and it was friggin' beautiful, and I put it in the ball the day of Rogue One, and I pushed forward, and the servo went, and the head went. So, different types of servos, different levels of servos are real. The $250 servos are not $250 because we're trying to make money. It's because it's a radically different product. The servos that I originally put in here, that Stefan also used as well, really high torque rating, really good ounceages, really good everything. They're crap. They're, and they were like $40 or $50. So one of the things you're going to find when you start talking about the drives and what's in them, the commonality between at least the ones that are using the servos. Dave, I think, also probably started with different types of servos as well. In the end, it's kind of funny because even though Dave and I talk, we ended up with the exact same servo. And in the end, it's a $250, $300 servo times 4 in one drivetrain alone. So building drivetrains and getting them on a performance level is not a cheap route. Yeah, there is no cheap route, that's what I should say. Every single time that we went back and we said, you know what, let's figure out how we can cut costs doing this. Every single time we did it, the drivetrain failed. You put the thing together, you spend all the time, you put it in BB-8, you drive it forward, and it fails. You take it back apart and go, there's the cheap part again. So there is definitely a relationship between cost and performance as well.
The reason why you take so long to release the drive.
Yeah.
Because beta testing is more
I've been
expensive than anything else.
And Matt's question, was why does it take me so long? Or why does it take so long to release my drive? You know, especially since I did show it off. I showed it rolling a week or two before Rogue One. I beat the hell out of everything. You'll find that when I release a skeleton, it doesn't fail. When I release a BMM DMM mount, it doesn't fail. It's because not only do I beat the hell out of everything, I usually have a few trusted people that build what I build, and we all beat the hell out of it. And by the time I release something, I release it because it's bulletproof. I don't want to release this and a week later go, well, I forgot about this. And then you've got to recut metal, you've got to reprint something, you've got to do this and you've got to do that. I want to get to the point where when I go, here you go, club, this is yours, you guys can build it and go, it works. It doesn't fail. It's been designed, it's been tested, it's beat up. So, yeah, you've been hearing about my drive coming for a really long time. Well, that's because I wanted to beat the snot out of it. One of the things that people here didn't know before they came to this event is they're going to have access to my drive extremely soon, quite a few months before the rest of the club. So that's going to be coming down the path. They'll probably have access within a month or so. So you guys will have brand new toys to build. Let's see, what else? Any other comments, questions?
Violent disagreements?
The what?
Violent disagreements?
No, violent disagreement. No, we didn't. You know what? We had lots of beer last night and margaritas, and we were good. There was zero violent disagreement. Matter of fact, I think everybody had more fun, so break out the margaritas. So if anybody has any questions, let me know. This wasn't supposed to be really in-depth on exactly which servos and things like that. This is more of a general A to B, here's how it works, and if there's any questions, just PM me on Builders Club. Thanks. Bye.